All right, we're going to talk about the mean value theorem, do a couple of problems, number 13 and 14. It looks like number 3. Recall the mean value theorem, it has to have some things satisfied. First of all, it has to be a continuous function on a closed interval, and it has to be a differentiable function on the open interval. And if that's true, then there is a number c in between a and b, between the interval, such that the instantaneous rate of change, the derivative, is equal to the average rate of change. All right? So now, we have a problem up there, number 3 or 13, where f of x equals 3x minus x squared on the interval 2 to 3, a closed interval. And we can immediately recognize 3x minus x squared as a parabola. And we know that that has continuous on that interval, and we also know it's differentiable. And if we take the derivative, we can see that f prime equals 3 minus 2x. So if I enlarge here, we know I have the mean value theorem written here. We now know that it's going to be satisfied. It has to have a value of c. So what I did is I just found the values of f of 3 and f of 2 from up here. And I did it. I set the derivative equal to the average rate of change. And I get a value of 5/2. So since it's differentiable, and again, 3 minus 2x is the derivative, and it has a derivative everywhere on the interval, and we know that the mean value theorem applies. If I erase this up here, the mean value theorem applies, c equals 5/2. Again, and is that inside the interval? Yes, it is. So that is the answer to number 13. Number 14 is a multiple choice question, and I'll tell you right now that the answer in the book is incorrect. So that kind of probably give you a tip off, all right? So again, mean value theorem, it says the function is negative 1 over x, or I see it as negative x to the negative 1 power on the interval negative 3 to negative half. And again, the only asymptote is 0, so it's continuous on this function. And we know there's a derivative that's continuous on that function, so it's differentiable on that function. So it's saying that the mean value theorem applies that the instantaneous rate of change is equal to the average rate of change. All right. If we do the math here, all right, and this is important, I'm going to get this a little bigger. I found that the derivative of negative x to negative 1 times negative is a positive, negative 1 minus 1, x negative 2, or 1 over x squared. That's the derivative. The average rate of change, again, using this formula up here, I found that negative half was 2 and negative 3 was a third, so I get 2 minus a third over negative half minus a minus 3. Using my calculator, 1 2/3 divided by 2 1/2 was 2/3. All right? And I got 1 over x squared equals that. Now, this is where the book made the mistake. You cross multiply, and you get 2x squared equals 3. You divide by 2 and take the square root, you get plus or minus 3/2. We immediately should throw away the positive one because that is not in the interval. That leaves me negative square root of 3 over 2, which is in the interval of negative 3 to negative half. You'll notice that the mean value theorem applies, so we can get rid of c and d. It applies because it met conditions. All right? Now, the answer is none of the above because the value should be 3/2. I think the book made a mistake, all right? And it says A is the answer. It didn't do the square root right. But B is a sucker answer because it kept the plus and minus when the positive value is not in our interval. That said, what it has written there is A, but in our case, the answer is E. Again, mean value theorem. A function continuous and differentiable. It's guaranteed that the average rate of change and the instantaneous rate of change will be the same at least at one point, maybe more.